Hello, students. Welcome again. We are going to look at the keys still on relative velocity. Assuming you have a river, right? Let's say you have a river and the river is this wide, okay? And then we have the river flowing towards this direction. Let's say the river is flowing towards this direction. And someone, let's say a steerman or let's say a ferryman, is in a boat and he wants to cross this river at right angle, okay, to the other bank. So if a ferryman wants to steer a boat at right angle across the bank, you all know, bear with me, that because the river is flowing towards this direction, it will not be easy for him if he wants to get, let's call this point B, okay? If he wants to get to point B exactly, it will be very difficult if he is to go right angle straight like that. So what will he do? Technically, he has to, let's say, go this direction. He has to go this direction, so that after going this direction, after some time, you can finally and safely steer and arrive at point B. So that is what we are going to look at for in this lesson. So we have this ferryman's problem. So consider a man who rows a boat in still water at velocity. We are calling the velocity of the river Vm subscript m. And if he wishes to row due north, okay, across a river which is x meters wide. Now we are assuming that the river is x meters wide, and the river is flowing towards the east. Okay, all right. And the velocity with which the man wants to, the velocity of the river is Vr. Then this diagram is summarizing the problem. How does it summarize? You see, the river is moving towards the east. The man wants to move at right angle. Okay, so what direction must he move? He must move this way before finally coming here. So this Vm becomes the velocity of the man, or the velocity with which the man rows the boat. Right. So what are we trying to say? We are defining our terms here. The direction in which the man must steer the boat, according to our diagram, is the theta. Then Vm, I think Vm, okay, I've defined it already. Then the resultant velocity, in other words, instead of moving straight from here to here, he can move this way, then finally this way. That is the resultant velocity. Okay, all right. We are using this symbol for it, the resultant. You can use any letter, but we are using VMR. Okay. Then the time taken for the man to reach the other bank, because we are giving the width of the river, we are saying it is x meters wide. All right. We know already that velocity, mathematically, we find velocity as what is displacement over time, right? So if we want to find the time, then what do we get? Time is going to be displacement, which can be, in some case, we can say distance. The difference is that the displacement is a vector quantity over velocity. So if you want to find the time it will take for this man to move from here to here, all right, to move from here to here, then we are saying it is the resultant velocity according to this equation, okay? So we can call this distance, okay? Here we are using distance, right? So here is going to be the width of the river. Here the width of the river is the distance over the resultant velocity, just like what I have done here. All right, let's pick nice example, nice question on this. A river which is 150-meter wide has water flowing at a velocity of 1.8 kilometers per hour. A ferryman who can row in still water at this 2.5 kilometers per hour wants to cross the river at right angle to its bank. You see, so this question explains what I was talking about, right? Find the direction in which he must steer the boat, time it takes for the man to cross. Okay, so solution. As we know already, so simply we have this diagram we need to draw. According to the question, it says, where is it? The river is 150 meters wide. Okay, so let's do this. Should I increase the thickness of my pen a bit? Okay, so it says it's 150. So the river is 150 meters wide. And according to the question, we want to row at right angle. Okay, so if he wants to row at right angle, we know that the man must move this way before he finally arrives here. So let's call the direction in which he must steer the boat theta. This will be at right angle, of course. Then this will be the velocity of the man. Okay, then he says the river is, according to the question, the river is moving due east, so velocity of the river. And when we transfer this one to the diagram, it's going to be VR here. All right, so what do we do? So we can redraw, get this diagram. This is the velocity of the man, and according to the velocity of the man, the question says Vm. Okay, this is Vm, this is Vr, so this is going to be our resultant velocity. So you can use VC or whatever, any letter. You can still use the V. You can use the letter I used in the notes. All right, so we need to define our letters, parameters. So where on my next page, where Vm is the velocity of the man, Vr is the velocity of the river, then the Vc, we are calling it the resultant. You can use the letter I used in the note. It doesn't matter. According to the question, what is it saying? The water is flowing at 1.5. So you are given the velocity of the river, 1.8 kilometers per hour. And how do you find this in meters per second? It's 1.8 times 5 over 18. Or in other words, you can say that 1.8 times 1000 over 3600. And this gives you what? 0.5 meters per second. The reason being that the question has already given the width of the river in meters. So you can't work meters and kilometers per hour. All right. Then when you continue with the question, it's giving us that a ferryman who can row in. So here is the velocity of the ferryman. The velocity of the ferryman is 2.5. So it's 2.5 kilometers per hour. And this is also 2.5, 2.5 times 5 over 18. And this gives us, according to your calculator, check 0.694. Okay, so 0.694 0.694. I'm looking for somewhere better to write it. I think it can go under. So 0.694 meters per second. All right. So what are we saying? Now the resultant velocity, the question wants us to find the direction in which he must steer the boat. So we are looking for this theta. All right. And if we are to transfer our values back to this diagram, we will get the velocity of the man to be 0.694 meters per second. Then the velocity of the river has been found to be 0.5 meters per second. So he wants us to find the direction. And according to trigonometric ratio, we know two sides, okay? Okay. So this is our opposite, the 0.5 is our opposite, the 0.694 is our hypotenuse. So sine, okay? So you can say that, let me call this figure 1, figure 2, okay? So I can say that from figure 2, okay, sine theta is what? Opposite, which is 0.5 out of 0.694. So that my theta is my sine inverse of 0.5 out of 0.69. And this, according to our calculator to 2 decimal places, gives me 46.09 degrees. So I will say the ferryman. So this is the first part of the question. The questions are in two parts. The question is in two parts. I. Okay. So I. So the man must steer the boat at 46.09 degrees. Good. Then let's answer the second part. The second part is talking about the time it takes to cross the other river. See, let me redraw this diagram. Look at this diagram. If I were to transfer this diagram here, you see figure 2. Okay, let's even discuss it here. Time to cross the, so we are looking for the time it will take to move from here to here. We are looking for that time. And if you know this velocity, then it becomes easy because you already know the width. The width is the distance. So you see, this diagram is talking about velocity. But when you transfer this to here, it becomes what? Displacement or distance. So it's like finding this. If you find VC, you will know velocity and you will know this distance or displacement. I don't know if you get a picture. This is the diagram actually. This is how the diagram looks like. It has already been drawn. Let me see. Yeah. So this 150 is the same as this side. And the velocity is the VC. So knowing my VC, it will be the velocity, okay? And the distance of separation is also 150. So knowing that distance and that velocity there, I can easily get the time it will take for him to cross. So here our work is to find VC. All right. You see, looking at this, we know it's a right angle triangle. Knowing two sides, we can find the third side using the Pythagoras theorem. Okay, so I don't want to complicate things. So let me just move on straight. I don't want to redraw again. Applying the Pythagoras theorem. Okay. Pythagoras theorem to figure 2. What do you get? If you want to apply Pythagoras theorem to figure 2, then it's going to be the hypotenuse squared, which is a 0.694 squared equals 0.5 squared plus our VC squared. So what do we get? is going to be our 0.694 squared minus 0.5 squared is equal to our VC squared. Is that not it? And when we simplify this, we are going to get 0.231636 VC squared. So that eventually taking the root of both sides, we are going to get VC. Are you following? So what do we get eventually? Our VC to 3 decimal places give us 0.481 meters per second. So in other words, what we have gotten is that we have known the velocity of this. Okay, this velocity. Let me change the color. We have known this velocity to be what? 0.48. We have gotten this to be 0.481 meters per second. And luckily for us, the distance from this to this is 150. So velocity and the distance. From there, we can get a time, isn't it? Okay. So I time taken to get to the other bank, as we said, is the width of the river over the resultant velocity. And the resultant velocity of our VC. So it's 150 over meters per second. Sorry, 150 meters. And the resultant velocity is 0.481 meters per second. The meters goes out, and when you work this out, get 311.85 seconds. All right, so students, this answers the question there. Take your time, pause the video, go through again. This answers the question.